In this section, we'll talk about exponents and a few exponent rules. First of all, let's remember what exponents are. There's a base, and a small number up here would be exponent, and we call them powers. So we have base, exponent, and everything together is considered to be a power. And we can define certain ideas. We can define a to the first power to be just a. In other words, we won't always write the 1. If we don't see anything there, we'll assume it's a 1. We can also define something called the 0 power, and we'll define the 0 power to be 1 no matter what the base is. If you raise it to the 0 power, you'll get an answer of 1. And one other definition for our work right now is a to the negative n power. Now, when we see a negative exponent, we are not indicating that there's negative numbers, not at all. What we're indicating is that if you see a negative in the exponent position, you need to think reciprocal, because the definition here is 1 over a to the positive n. Now, with that in mind, we can go on and look at our 2 rules that we're going to look at in this section. And the first one is that a to the m power times a to the n power is a to the m plus n power. Now, with this in mind, we need to be able to say this carefully. This says this is a to the m power, and this is a to the n power. So what we're doing is we're multiplying powers. But more than just multiplying 2 powers, we're actually multiplying 2 powers with the same base. So when you multiply powers with the same base, you wind up with a new power with the sum of the exponents, but also with the same base. It's important for us to remember then that we have the same base throughout. All 3 places have the same base. And once we see that, then the adding the exponents part can be very helpful. Now let's look at a couple of examples of how we might do this problem using this rule. So suppose we have t to the 5th times t. What do we have here but t to the 5 plus what? Well, we assumed it was a 1. So that's 5 plus 1. That's t to the 6th. Another place we might apply this, and I'm giving you some problems where we might make mistakes if we're not thinking carefully, is 2 to the 3rd power times 2 to the 4th power. And that would be, here's where it isn't handy to say, oh, I have a product of 2 powers that have the same base, so the product has the same base to the 3 plus 4 power. And that gives us 2 to the 7th power. Now 2 to the 7th power is 2 times 2 times 2 times 2 times 2 times 2 times 2. And 2 to the 7th power then is going to be 2, 4, 8, 16, 32, 64, 128.